Look at this. Today we will do a quick dive into Xiaomi's MIMO VL7B, a compact 7 billion parameter vision language reasoning model that outperforms larger competitors like OpenAI O1 Mini and Qwen 32B thanks to sharp data curation, reinforcement learning, and real-world GUI demos. Most people believe only massive AI models can deliver true vision and reasoning power. What if I told you a model 10 times smaller just one-upped those giants? In this video, I'll break down Xiaomi's training secrets, data tricks, and RL strategy that made this model insanely effective. I've analyzed every stage and benchmark. I break it down for YouTube pros looking to build smarter, not bigger. A year ago, running a top-tier AI vision model meant plugging into a server rack the size of a fridge. Today, Xiaomi's MIMO VL7B does it on a gaming PC, and it's outperforming models 10 times its size. How? Not with brute force, but with strategy. This 7 billion parameter model is rewriting the rules of AI development, showing that smart beats big and precision beats bulk. But this isn't just about making models smaller. It's about building a system that can see like us, think like us, and respond in ways that feel surprisingly human. While the rest of the industry focused on scaling up, Xiaomi went in the opposite direction, and somehow they may have leapfrogged the entire field. This is the wild story of how a lightweight rebel just disrupted the AI elite. Small but savage, the 7B shockwave. When most people hear 7 billion parameters, they don't expect much. After all, that's less than a quarter of GPT-3's size and a fraction of models like Claude Sonnet or Gemini Pro. But Xiaomi didn't build VL7B to win a size contest. They built it to win a fight. The industry has long treated model size as the ultimate performance indicator. The bigger the model, the smarter it must be, right? MIMO VL7B blows that assumption apart. Despite its modest size, it competes head-to-head with 30 and even 70 billion parameter systems across vision, reasoning, and multimodal tasks. And here's the kicker. It runs smoothly on consumer-grade GPUs. No fancy data center, no high-end TPU clusters. Just a solid gaming PC and some optimization. That alone makes it revolutionary. It means powerful AI can become accessible. Not just for big labs or corporations, but for independent developers, startups, and even hobbyists. But the question still stands. How is something this small so capable? That's where the architecture comes in. What's inside this tiny beast? At the heart of MIMO VL7B are three simple yet highly effective components, working together in perfect sync: the vision transformer, the projector, and the language backbone. First, the vision transformer. This is the model's eye. It looks at images in full high resolution, preserving every detail. Most models compress visual data, sacrificing clarity for speed. MIMO doesn't. It processes images the way a human might, without blurring out the edges or skipping over fine print. Like this video? Then hit like and subscribe to help us with the algorithm and show the video to even more people. Next is the projector. It's small but crucial. Think of it as a translator. It takes the raw image data from the vision transformer and converts it into a format the language model can understand. Without it, the entire system would be like a person who can see perfectly but doesn't know how to describe what they're looking at. And finally, the backbone. MIMO7B. This is where the language and reasoning happen. Unlike typical language models that focus on snappy replies, this one was tuned from day one to think out loud. It prefers full, thoughtful answers. It doesn't just respond, it reasons. Together, these three pieces form a streamlined, high-performance AI engine. But great parts mean nothing without the right training, and Xiaomi's training pipeline was nothing short of brutal. The 4-phase gauntlet, brutal training regimen. Most AI models get trained once and then fine-tuned a little. MIMO VL7B went through 4 massive, grueling training phases, burning through 2.4 trillion tokens along the way. That's trillion with a T. Phase 1 was the warm-up. The vision and language pieces were frozen, only the projector was learning. It studied 300 billion image caption pairs, learning what a carrot looks like, and how to link a photo of a streetlight to the words traffic signal. Basic stuff, but crucial for building intuition. In Phase 2, the vision module was unfrozen. Now it could adapt, learning side by side with the language model. They were fed 167 billion lines of mixed data, web pages, textbooks, PDF snippets, all to teach the system how pictures and text play together in the real world. But Phase 3 is where it gets wild. Over 1.4 trillion tokens poured in, covering everything from blurry phone photos to diagrams in science books, app screenshots, even short video clips with perfectly synced captions. By Phase 4, MIMO was ready for long-form memory. They cranked up its token limit to 32,000, enough to take in entire chapters, detailed images, and still keep space for deep reasoning. It wasn't just about recognition anymore, it was about understanding. That phase also introduced something rare in model training: reasoning data. Not just answers, but explanations. The model wasn't told what, it was shown how. Step-by-step logic, written out explicitly so it could mimic real human thought. And as we'll see next, what truly set Xiaomi apart wasn't just how much data they used, it was how carefully they used it. Ruthless data curation, Xiaomi's secret weapon. Most companies scrape the internet, toss the data into a blender, and hope for the best. Not Xiaomi. Their data pipeline was a scalpel, not a hammer. They used perceptual hashing to filter out test set overlaps, ensuring the model wasn't cheating by memorizing examples. They recaptured images with a specialized captioner that improved context and grammar. They even filtered image-text pairs based on something called knowledge density, keeping only the content that actually teaches the model something useful. For optical character recognition, they made sure the model saw messy examples, blurry text, handwritten notes, images with text partially obscured. Why? So it could handle real-world messiness, not just pristine lab examples. Videos were captioned scene by scene, each with exact timestamps, so the model learned how events unfold in time. And because many interfaces in China are in Chinese, they created synthetic screenshots with Chinese buttons, ensuring the model wouldn't freeze when it saw unfamiliar characters. Xiaomi didn't just gather massive amounts of information, they refined it. They sliced away fluff, recaptioned content for clarity, even simulated Chinese UI screens to build real resilience. This level of precision is what transforms raw data into trustable knowledge.
Imagine two states of the world, one in which the entire world runs on American open source LLM, and the other runs on all Chinese software. By Mark Andreessen Horowitz VC, on businessinsider.com.
This isn't just a technical feat, it's ideological. Xiaomi openly shared weights and pipelines, ensuring this model puts sovereignty and cultural alignment firmly in skilled hands. This wasn't training, it was crafting. Xiaomi didn't just build a model, they engineered a brain, and yet they weren't finished. Chain of thought reasoning, teaching it to think. At this point, MIMO VL7B could see clearly and speak fluently, but Xiaomi wanted more. They wanted it to reason, not guess, not parrot answers, but actually think through problems like a human. So, in the final stages of pre-training, they injected the model with something most AI systems never get: chain of thought data. This meant feeding it problems that required multi-step logic, then walking it through each step of the solution. No shortcuts, no one-word answers. This is where MIMO starts acting less like a chatbot and more like a tutor. Ask it a science problem, and it doesn't just spit out B. It explains why B is right, shows its logic, and exposes the assumptions behind its answer. And because it was trained with longer context windows, up to 32,000 tokens, it doesn't lose track halfway through. It can remember the setup, analyze the data, reason it out, and still have room to wrap things up with a full explanation. This is huge. Most models can't keep track of that much information, let alone use it effectively. MIMO's ability to maintain context and produce long, coherent reasoning is what sets it apart. But reasoning in a vacuum isn't enough. It needed to learn how to make its answers better, to adapt on the fly. And that's where Xiaomi turned up the heat with a reinforcement learning method most labs wouldn't dare attempt. Reinforcement learning, the final test. Enter MORL, Mixed On-Policy Reinforcement Learning. Sounds like a mouthful, but the core idea is simple. Let the model try, grade its answers, and then update it immediately based on how well it did. This is the opposite of how most models are trained. Usually, feedback gets stored, averaged out, then applied in bulk. Xiaomi tossed that out. With MORL, every single answer the model generates is judged in real time, and that judgment instantly updates the model. MORL isn't just about math accuracy, it's about shared learning. The model adapts in real time, but more importantly, it learns in public. That kind of transparency fuels collective progress.
We'll train our open source platforms in a distributed fashion with data centers spread across the world. They will contribute to a common model that will essentially constitute a repository of all human knowledge. By Yan LeCun, Meta's chief AI scientist, on businessinsider.com.
And that's exactly what Xiaomi did, sharing checkpoints and evaluation systems so researchers everywhere can pick it up, improve it, and push the model forward together. There were two types of rewards. The first is verifiable, stuff you can check with a script. For example, if the model draws a box around an object in an image, you can measure how close it got to the correct target. If it solves a math equation, you can plug the answer into a calculator and check it. The second type is preference-based. These are fuzzier tasks, like writing helpful advice, staying unbiased, or being polite. For that, Xiaomi trained reward models, one for pure text, another for multimodal inputs. These systems looked at thousands of human-ranked answers and learned what people like. Crucially, MIMO was rewarded in a way that avoided cheap tricks. Long answers weren't rewarded just for being long. Rewards were scaled by answer length to stop the model from padding. Feedback was normalized, kept tight, and delivered with millisecond-level speed thanks to a tiny web service that wrapped each reward function. All of this meant the model was constantly learning. It wasn't just updating between training runs, it was evolving during them. And the results? They speak for themselves. Mind-blowing benchmarks, punching above its weight. After reinforcement learning, MIMO VL7B wasn't just good, it was elite. On benchmark after benchmark, it started crushing expectations and outperforming much larger models. On MMU, a test spanning multiple subjects and tasks, its accuracy jumped from 64.6% to 66.7%. On Char-C, which evaluates chart and document understanding, it soared to 56.5%, eclipsing larger open-source competitors by double digits. Its counting accuracy hit over 90%. It tackled the vision language trap test, designed to trip up models with tricky images, at nearly 80%. That's strong even by commercial standards. And it wasn't just visuals. On text-only math problems, MIMO scored an incredible 95.4% on the Math 500 benchmark. It handled real-world math competition questions, stuff most college students would sweat over, with over 50% accuracy. But the biggest shock came in science. On the Olympiad benchmark, packed with diagram-based problems, MIMO held its ground against models more than 10 times its size, scoring 59.4% on math. Heavy problems and a staggering 71.5% on diagram reasoning. It matched or beat models like Qwen VL72B, some of the largest open-source vision models on the planet. And it wasn't just smart, it was practical. Real-world utility, shopping demo, and agent readiness. What's the point of all this reasoning and recognition if a model can't do something useful? Xiaomi answered that with a jaw-dropping demo. They opened an online store page, then asked MIMO in plain language to find a specific car model with a custom paint job and interior and add it to a wish list. No special instructions, just a screenshot and a request. MIMO parsed the image, spotted the right color swatch, scrolled to the trim options, clicked Add to Wish List, and then output a full JSON action trace that any automation controller could run directly. Think about that. A model looking at a cluttered GUI, understanding the task, and generating a precise, executable plan to get it done. No human in the loop, no scripting, just vision plus logic working together. That same model can now read invoices, identify labels, solve grade school math, and navigate real-world software interfaces, all without any hand-holding. And Xiaomi isn't keeping this locked up. The checkpoints are open, the training code is public, the benchmark harness spans 50-plus tasks. Anyone can replicate this. It's not just a model, it's a toolbox, a glimpse into the near future of agentic AI, where intelligent models don't just talk, they act. MIMO VL7B isn't just another open source release. It's a warning shot across the bow of the AHI industry. First, it proves that small models can still get smarter with the right data and training design. Second, it shows that reinforcement learning, done carefully, can dramatically enhance reasoning and alignment, even in smaller architectures. And third, it reminds everyone that performance isn't about raw size anymore, it's about purpose. With MIMO, Xiaomi has done more than shrink the AI footprint. They've sharpened it, focused it, given it structure, and now everyone else is playing catch up. So here's the question. Will small, sharp models like this eventually wipe out the need for massive AI stacks? Or will we always need giants to stay on top? Drop your thoughts below, and if you're into this kind of cutting-edge tech breakdown, make sure to subscribe. This space is changing fast, and you won't want to miss what's coming next. Thanks for watching. Take a deep breath and check out the links in the description. I'll see you in the next one.